Instead of listing all of the trig functions and their integrals, they're all available to you on page 339. Half of them you should know just by the fact that we've been using them so much. For example, you should know that for sure its antiderivative is sine. So that wouldn't be anything new for you. There's two new ones in here, but I'm not going to even put them on. If they pop up in your homework, you can go find them on this page. They won't be on the AP exam. For me to prove them takes too long. I prove them in Calc 2 actually, but most of these are ones you should know. You should know that one. What's this one? Tangent, yeah, but the whole list of all the trig ones you ought to know right now is on page 339. So I'm going to save a little time and just move along. I think you have them memorized anyway. So in the key concepts box in 5.1, we did our new antiderivative, and the antiderivative of x to the negative firsts, or 1 over x, is the natural log. Remember, it's absolute value of x because we can't natural log negatives outside the domain. We have our good friend Carl. And then likewise, this is just from yesterday. This is natural log, absolute value of u plus c. But if you watched those notes yesterday, I really stressed that you need to manufacture that du before you do this method. So today we're going to do a few new ones, give you a couple more tools to use, and then we'll be done. So general rule, integration gets tricky, but a general rule is that you let u be the inside function. If I did that on this one right here, I'll call it number 1. If I let u be secant, because that's an inside function and that's what I've told you to do, your derivative is secant tangent. It's not helpful, right? If I let u then be the denominator now, if I can get its derivative in the numerator, I'll have generated this. And we know that that is the natural log. So that's a go-to now, is to let u be the denominator. The derivative of u is secant squared. I don't even really need to write this one down if I spot it. I'm staring at 1 over u, and the rest of this is du. So this is a straight in-your-face natural log antiderivative. It'd be the natural log, absolute value of u, plus my good friend Carl, right? It's kind of easy, that one was, right? Now you could test it. Do you remember how do you test it? How do you test them? See if it's right. Take its derivative, yeah. The derivative of the natural log function is 1 over u times du, or u prime over u, and it sends me right back to the integrand. So that one was straightforward. This one's not as straightforward, but you only have so many options. So you really, this is obviously u sub. You don't know it just by staring at it. Your only option is to let u equal x to the 2/3, or let u equal this chunk of stuff. What does your gut tell you to let it be? The chunk. Because of that +1, you want it to go to 0 in the derivative. So you're right. Let's let u equal. If this doesn't work, it means that your teacher's got to teach you some other method, right? I can't just leave you hanging if u sub doesn't work. So there are other methods. Actually, for Calc 1, you're done though. You're done with all, there's one more method for E. But other than that, we're pretty much done with all the methods till you get to Calc 2. U sub is the big one. So I'm going to let that be U. I'm going to take the derivative. All right, let's do that. I'll just call on somebody. Dalton, what's the derivative of x to the 1/3? Could you do that? Yes, and x to the negative 2/3, I'm going to throw down here in the denominator. Exactly. And the 1 goes to 0. So there it is. That's super close to what I want, right? What's the problem though? Yeah, the 1/3. So I'm going to get rid of it. I'll just multiply fraction correction it with a 3. And I get 1 over x to the 2/3 dx. And if you go back and take a look, that is the entire rest of this. So I can replace that whole little red blob there with a 3 du. And it looks messy, but I'm going to go clean it up over onto this side here. I started off letting u be part of the denominator. The whole rest of it became 3 du, and I pull the constants out front. So I like the 1 over u du. Do you see why I've been stressing that more than the u prime over u? It's a little easier when you integrate. All right, I'm almost done. Rachel, what's the antiderivative of 1 over u? Yeah, ln of what? absolute value, thank you, x to the 1/3 plus 1. And then Carl hangs along for the ride, and it's done. Those could have been on your worksheet yesterday, and I think there were similar ones to that. So what's new today? Well, I got to give you another couple little things to try. So if you were to attack this one with no new tools in your tool belt, you would say, well, there's no inside function really. It's obviously u sub. It doesn't make a heart that I can break apart. It's nothing that's in my face that I know. If I let u be the numerator, the derivative is 2x plus 1. That's not helpful. If I let u be the denominator, I get 2x. That's totally not helpful. So here's another thing to try. If the degree on the top is greater than or equal to the degree on the bottom, in this case it's equal to, you can use long division, which you haven't done since do you do long division in pre-calc? I don't think you've done it since Algebra 2. And when you were in Algebra 2, you learned how to do it, but you never had to apply it because you couldn't, because you didn't know how to integrate yet. But integration is where you apply that long division skill. What it will do is it'll break this into workable pieces. So let's go give it a whirl. I'm going to take the x squared plus x plus 1, and I'm going to physically, with some long division, divide it by x squared plus 1. And I'm going to review this process because if you didn't do it in pre-calc, it's been 2 years. So let's go take a look at how you do it. Let's mimic it with just something nice and easy over here, like 25, let's make it 75 divided by 3. We're going to mimic that with our long division. When you divide numerically, you say, well, how many 3's go into 7? Or equivalently, you do 7 divided by 3 and you get a 2 with some leftovers. So you put a 2 right here, right above the 7. Same thing here. You do x squared divided by x squared and you get a 1, right? You put it over here because it was a constant. If you get an x of some sort, you'd put it above this one, x squared above that one. Then you do what you do over here. You'd say, well, 2 times 3 is 6, so I got to write that down. I'm going to do the same thing over here. So 1 times this stuff is x squared plus 1. And then in elementary school, what they tell you to do with these two levels over here? Subtract them, and you would get a 15. Oh, I have one that goes in there nice. Let's pretend that was a 6. And you get a 16. Sorry, I didn't realize it was divisible by 3. So I'm going to subtract these. X squareds are gone. I have an x, and 1 is gone. All right, so when you get over here and you start again, you go, well, 3 goes in there 5 times. I have a 15. Now there's 1 left over, and it's less than 3, so I'm pretty much done. I'm at the end of my dividend, and I've got something less. How did you write your answer back in elementary school? 25 and what? 1/3, which is really 25 plus 1/3, right? That's how we're going to write this. We're going to say, well, my remainder is x, and it is less in degree than x squared. So I'm done. Plus, I'm at the end of my divisor right here. So I'm going to say plus x over x squared plus 1. You did that in Algebra 2 quite a bit. And then you learned synthetic, right? But synthetic's not helpful in this situation, so we aren't going to do any synthetic. We really need to see it broken down. I'm going to rewrite the integral. 1 plus x over x squared plus 1. Now I can use this. Now this is going to be easy, right? Sammy, what's the antiderivative of 1? Whoopsie. X. That's done, right? So that part was nice. And then I have this. And somebody tell me how you can tackle that. I can't, it's an upside down heart, so I can't really break it apart. So I'm going to use a different technique. When there's a fraction, who do we try letting u be? The denominator, right? And you hope that its derivative is living in the numerator. And in this case, it's super close, correct? My derivative is 2x. Super close to what I want. What do I just need with it, Rebecca? Yes, a 1/2 fraction correction. So I'm going to do that. Some of you might start doing this little u sub, the one-step u sub in your head. I'm okay with that as long as you're accurate. What I mean by that is, some of you might say, well, okay, u is the denominator. This is actually 2x dx, so I need a half of that. And you might go from here right to here now, because you've done it enough. Almost there, right, Krista? Because what's the antiderivative of 1 over u? ln of absolute value of u. Now suppose she left the absolute value bars off. Could I mark it wrong? What do you think? In general, yes. In this specific example, no. Can you tell me why not? There it is. X squared plus 1 is what? Always positive, so they're redundant, but I would put them on there just in case, because if it matters, you'll get it marked wrong. So that one was a little bit trickier. We are going to move along. And this is from your book. It's kind of interesting right here. So integration's tricky. It's way harder than doing a derivative because you're really trying to undo something or figure out what the original thing was. You're working backwards. This is what your book says on page, I think it's like 237, right in this section. Here's what your book says. It says that you need to be successful. Here's some guidelines. Learn your basics, right? Well, duh. You know that the derivative of sine is cosine and the antiderivative, blah, blah, blah. It says know your rules, know your power rule and your log rule, know all your trig stuff, and we'll eventually give you some more. So this is sound advice. Wouldn't you agree? Let's look at number 2. It says find an integration formula that resembles all or part of the integral. Use a little trial and error and try to make yours conform to it. Now, this does not sound like math, right? That did not sound like math. When it says resemble, trial and error, conformity, they're basically saying you just got to work with it. And you got to try to get it to work. And if you can't find u sub that works, they say try changing it. Like messing with it. Like if you see a tangent, change it to what? Sine over cosine. Or if you see something that can be cleaned up, try doing that because maybe then you'll fall onto something that works. And then it says, be a little creative. That is not math advice. Be creative, trial and error, conformity, and then this is the kicker. I love it. This is in our book, by the way. That's where I screenshot this. It says, if you have access to computer software that'll do it, just cheat. So if all else fails, consult Google and it'll probably tell you the answer. So this is our textbook. I didn't make this up. Basically what they're saying in all of this is the struggle is real. And we can't really give you a definitive approach to every problem. You just need to fart around with it, be really good at the basics, mess around with some stuff, think outside the box, and if you're stuck, go cheat. That's what it's telling you. Seems kind of weird. We're not going to go cheat because you won't have access to that software. So we've got to somehow make those guidelines a little bit more rigid. So here's what you're going to do. When you see a fraction, if it makes a heart and there's a single term on the bottom, you will break it apart. That's a really good tool. That doesn't work here. When you see a fraction, who are we going to let u be on first guess? The denominator. It fails here. That was a quick test, right? Then try the numerator. 3x squared minus 9, it fails too. I appear to be stuck, so I need to think more globally, and I need to come up with something else to get me started. What is it in this scenario? This is long division again. What is it about it that sets it up for long division? There it is. The degree on the top, it doesn't mean it's going to work, but it means you got to try it. That's what it means, trial and error. Try something. All right, I obviously can't use a trig identity, right? So I got to try something. We're going to try a little long division and see if we can make this conform to something that we can use. So let's see if you remember your long division. You stick to the left and you divide those. X cubed divided by x squared is just x. And you put it above that term. If there's terms missing, use zeros. All right. Then what do I do with the x? Just to remind you of the process. Do you remember what to do with the x? Yes, I heard it. Multiply it by x squared plus 3. Let's go do that. It'll give you an x cubed plus 3x. Make sure everything's lined up nicely. When you get your two levels all lined up, you subtract them. I'll get a negative 3x squared. 4x minus 3x is an x. And I also have a minus 9. My degree is not less than yet, so I have to go again. Plus, I'm not to the end of my dividend, right? So, Sophie, what do I do next? Repeat. I call this, when I used to teach this We actually teach this a little bit in exponential algebra, but I call this part wash, rinse, and repeat. Do it all over again. Stick to the left, do negative 3x squared divided by x squared, and get a minus 3. It's called an iteration. You're just doing the same process over and over again. It'll be a negative 3x squared when you multiply it, back in, minus 9. Line everything up, and I'm at x. I'm at the end of my dividend, and I have something less in degree. So I have to know how to write my answer, right, Kyle? I write my remainder as what? X over, there it is. All right, there it is. That's what I'm going to integrate. Those are equal. I just did this division, and I got that. So I'm really going to integrate x minus 3 plus x over x squared plus 3. This is going to be way easy for me, right? I'll pick on a few people. Mikey, what's the antiderivative of x? Great. Mr. Bazal, what's the antiderivative of 3? All right. Maddie Odegaard, is that you back there? I just saw the blonde poof on the top. Over the top of Sammy's head, I saw a poof of blonde. I had to make sure. All right, I forgot this was on, sorry. Anyway, Maddie, I'm not done with you. I want to know if this is something, and you're pretty good with your manipulation. Can you do this right here in your head now? Do you think? Could you think it out for me? Let's give it a whirl. Okay, just a second. I'm going to rewrite because I'm going to allow that right now. You've done it enough where the actual formally writing out what U is on a one-stepper maybe could be just done in your head. All right, it's equivalent to in geometry where they teach you to write this as the square root of 4, square root of 5, and then 2 root 5, but now you don't do that anymore. That's what I'm asking her to do. Can you do that? What would this be? Come on, Maddie. No, I'm purposely interrupting you. 1/2. And what is the antiderivative of 1 over u? ln. And I don't even need absolute value because that's positive for all x. And so I'm fine with that. But I'm telling you that I only think maybe half of you are ready to safely make that move. So don't do it yet. All right? It has nothing to do with intelligence. It's just that you just need to kind of get that as a natural part of your work process. But if you can't do it in your head, you're going to write u equals x squared plus 3. You're going to write du equals 2x. You're going to write a half du. But Maddie, that was super. Loved it. All right, next up. This one, there's only one in your homework. It won't be on your test. It's not on the AP test. But I still like you to be exposed to it. If you were taking this like at the U of M, you'd probably have one of these. They were fine with it this morning, actually. It's called change a variable. So again, I'm going to get stuck and have to be creative. So I'm thinking maybe U is the top. No. U is the bottom. No. Right? So I feel like I'm stuck, but my gut still tells me that U should be what? Who does your gut tell you it should be? X plus 1. It's the denominator and it's an inside function, and those are two big tells. So that's nice that that's a u. I can't mix my x's and u's. So dx and 2x need to have u's in them. So I'm going to do this. What's du? 1 dx. That's nice. I can replace u with a du. Who's my only problem? The 2x. So I have to be clever. Is there any way I could get 2x in terms of u? Do you see it? Raise your hand. Yeah, Chris. Sure. So keep going. Yes. Okay. He's messing around with this. Let's solve it for x. X would be what? U minus 1. Well, that would be nice because then I could do 2x. He did it a little differently. He doubled everything up here to introduce a 2x and then, right? That's what you did. This is just a little smoother, but your thought was excellent. So I'm going to rewrite that. I have 2x on the top. I'm going to bring the 2 out front because I like to do that, right? X is u minus 1. There's the top. The bottom is u squared. And then you have to dig into that. Again, I keep calling it a bunch of tools, but it really is. U sub's the hammer, but there's little tools as well. And right now there's a little thing that's going to help you get past that. There it is. Say it again. If it makes a heart, break it apart. That doesn't happen very often, but when it does, it's slick. I'm going to break this apart into u over u squared, 1 over u, sweet, love 1 over u. There. I'll pick on a couple people. Sabrina, why did I say sweet? I love 1 over u. It's ln. Are the absolute value bars necessary in that one? Yeah, that could totally go negative with different values of x, so you need them there. And then how about the antiderivative of this? What is it? Is it ln u squared? No, that's actually one in the top 10. College Board publishes top 10 student mistakes. I think I told you one of them already, that when you're doing the revolving solids, kids subtract and then square instead of doing big R squared minus little r squared. Another one, they call it the universal application of the log rule. So there'll be one on your AP test that looks like, I don't know, this looks so easy. And guess what a lot of kids circle? Guess what? ln x squared. They do. And you can only do the natural log when you have, this is really x to the negative 2. And what rule do we have for that? The power rule, right? So we're going to go power rule this. This is really u to the negative 2. We add 1, get u to the negative 1, and we divide by that. So we actually have this when we do its antiderivative. Let's clean that up. That would become minus a minus, and u to the negative 1 is 1 over u. All right, so that one's done. I'm going to put it in a box, and you're going to tell me what's wrong with it. Find it. Do you see it? Yes. I either need to put a 2 with this one as well, or I need to lock and load this. Do you think I need to put Carl in the parentheses? What do you think? Is twice a constant still a constant? Yeah, Carl just gets fatter, right? So it doesn't really matter whether he's in or out. Twice a constant, still a constant. Last problem of the day. This is, again, I'm putting what homework problems they're like, because this homework assignment's kind of, it's a difficult one. All right, solve the differential equation. What does that mean? Anytime you're asked to solve a diffie-q, all right, here's a differential equation. dy dx equals squiggly. Here's another one. Y prime equals squiggly. Here's another one. F prime equals loop-de-loop. There. I've got 3 differential equations. When it says to solve them, remember, what does that mean your answer should be? Like when it says to solve this, what am I looking for? No D, just Y. Solving a differential equation means what was the original function? What was the original function, and what was the original function? How do you think you go from a derivative back to an original function? It's an integration. It's kind of like velocity back to position. But we're going to keep the notation nice. So when it says to solve it, it means what was y? You took its derivative, and this is what you got. I want to know what the original function was. Yes, you do integrate, but we're going to write it nicely. We're going to whip the dx over onto the other side, just with a multiplication. I didn't do anything really. I'm trying to clear everything out so I can attack y. I integrate. This side is y, right? The antiderivative of 1. A lot of kids will just skip that step and say, oh, I know I need to integrate. You'll get the right answer. It's just bad math grammar. All right, here's my goal. So let's talk about how you attack this. Your book says know your rules, be creative, think outside the box, trial and error, use Google, right? Well, we've got to come up with something because that's not in my face, right? Who's the big tool in integration? U sub. It's the hammer. If that doesn't work, try something else. You have 2 options for U. Who do you think it is? ln, obviously. Yeah, Eva, U's going to be ln x. That's nice because then I have 1 over U. You might say, well, what about the rest of it? Well, what is the rest of it? du. Do you see it? Yeah, so U sub is the go-to almost always. When it's not working, that's when you get creative. This is set up for me. I've got 1 over U du. That's nice, right? Colin, what's the antiderivative of 1 over u du? ln, absolute value of u, and u is another ln. All right, so let's just circle that. And suppose this was the end of a test or your quiz tomorrow, because you're going to take a little quiz tomorrow. And suppose it was over, and I'm wondering, I have 9 minutes left before the bell rings, and I want to know if my integration's correct. How could I check this one? Do the derivative. And you can do it very quickly in your head. The derivative of the natural log function is 1 over u times du. Did that give me the original? See what I mean? It's perfect. It looks great. All right, so homework is listed on the front of your packet. There's just one I need to cross off. I'll tell you when it's due, and you should be able to get about half of it done in class today. I posted the full worked out key. I know you have Calc Chat. Sometimes that's not as clear. So when I think it's a hard assignment and I think Calc Chat might be have some ambiguity in it, I posted, oh, that you don't want to see. That's Calc 2. We'll get that out of there. There we go. All right. Here it is. You can take off number 33. It uses an obscure trig identity, one that we'll deal with later. So 33 can go. Here's your assignment. I don't know why these are in red from last year. I might have done it with them. Due on what day? Thursday. You're going already? You just got here. Okay. It's due on Thursday. Tomorrow, you're going to take a quiz/problem set. You're going to do it on your own. That one won't leave the room. So it's basically a quiz, and then you're going to get a short little worksheet to work on. So tomorrow I won't talk. You're going to come in. I'm going to let you use your notes. So if you've missed some notes, you should take them by tomorrow. So tomorrow a quiz, which I don't give very often, but I want to make sure we've got our ducks. It's not easy, by the way. Bring good notes. And then the work I give you today is due Thursday. Go ahead and start. I am done.